Now here the problem you see in the quadratic equation p square x square plus 4pqx plus 4q square plus 1 is equal to 0. P, Q are real numbers. P is not equal to 0. We have to discuss about its roots. That means roots are either real or complex, equal or distinct. We have to find it out. Okay, so how could we find about the root? We have to find out the discriminant of the quadratic equation. Okay, then we can conclude about the root. So here the equation is this. So comparing with the general equation of the quadratic equation, what we can say here, A is p square. Okay, B is 4pq and C is 4q square plus 1. Comparing with the general equation of quadratic equation, that means ax square plus bx plus c is equal to 0. So here for that general equation the discriminant is b square minus 4ac. So from here what we can get the discriminant, that is b means 4pq, b square minus 4a, a means p square, 4ac, c means 4q square plus 1. So that is b square minus 4ac. Okay, so find out, it simplify with first. So that is 16 p square q square minus 16 p square q square minus 4 p square. Okay, that means 16 p square q square minus 16 p square q square should be cancelled. So we are left here minus 4 p square. Now you see that 4 is a constant. P square, P is here given that P is a real number and P is not equal to 0. So square of a real number must be positive. So P square is positive, 4 is positive, then minus 4p square obviously a negative number. So that is less than 0. So what we have got, the discriminant b square minus 4ac is less than 0. So what we can conclude from here, that the equation doesn't have any real root. So roots are not real. So the conclusion is here, roots are not real. Okay. So here the given problem is that we have to find out the range of the values of n for which the given equation m plus 2 into x square minus 2mx plus 1 is equal to 0 has two complex roots. So what we know about the complex roots, what is the condition to have complex roots of an equation? We know that when the discriminant is less than 0, then the equation doesn't have any real root. In that case it has complex roots. Okay, so we have to find out the discriminant which is less than 0. So if we compare with the given equation to our general equation of quadratic equation, general form of quadratic equation, that is ax square plus bx plus c is equal to 0, where a, b, c are constant and a is not equal to 0. So comparing these with the given equation, we can say here a is equal to m plus 2, b is equal to minus 2m and c is equal to 1. And what we know about our discriminant, that is b square minus 4ac. So here we can get minus 2m whole square minus 4 into m plus 2 into 1. B square minus 4ac. Okay. So here it is. That is 4m square, and from here we can get minus 4m minus 8. Okay. And now the condition to have complex root, that is it is less than 0. Okay. So we get here we get here 4m square minus 4m minus 8 less than 0. Okay. Now we have to factorize this. So how we factorize? First of all, we take 2 common. So 2 outside, m square minus m minus 2 less than 0. So from here m square minus m minus 2 less than 0, dividing by 2 on both sides. So from here we can say that m minus, so here that is m square minus 2. So here if we take minus 2 and 1, that is m minus 2m. This gives minus m. That is our middle term. So here it is. So here we can write it here, m minus 2 into m plus 1 less than 0. Okay, we factorize this, we get m minus 2 into, we get m minus 2 into m plus 1 less than 0. So from there we have to find out the value of m, the range of the value of m where it belongs. So here you see that the terminal point is m is 2. When m is equal to 2, then the value of this expression is 0, and when m is equal to minus 1, the expression is 0. So one may happen m is greater than equal to 2, m is, we would not take equal to, as if the value is equal to 2 it becomes 0, which we would not consider because it is less than 0. So m is greater than 2, and another is m is less than 2, and another is m is less than minus 1, and another is m is greater than minus 1. So 3 condition is there. You see, one may happen m is greater than 2. If it is m is not greater than 2, m may be less than 2, and another is m is greater than minus 1 and m is less than minus 1. So 4 condition may happen. So if we take m is greater than 2, if we take m is greater than 2, that portion is positive, and m is greater than 2, that portion also be positive. So this multiplication of 2 positive gives us positive value, but our result is negative. So if we take m is greater than 2, it becomes positive. So this, we do not consider this part. Okay, it doesn't belong to the range of m. So now, it cannot happen. Okay. Now if we consider m is less than minus 1, if m is less than minus 1, m is less than minus 1, maybe minus 2, minus 2. If we consider m is less minus 2, then minus 2 plus 1, this part become negative. If m is less than minus 1, this part become negative, and if m is less than minus 1, this part also may be negative. Okay. So multiplication of two negative number gives us positive, but our result is negative. So this part also not be included in our range. Okay. Now we consider this part. If m is less than 2, m is less than 2, this part gives us negative value. And m is greater than -1, this part gives us positive value. Okay. Look at this. If we consider m is 0, it belongs to this interval. So if m is 0, this become -2. If m is 0, this become 1. So any value you take between -1 and 2, this part gives minus value, this part gives positive value. And multiplication of these two gives us a negative value, which is included in our range. Okay. So we consider this interval. So our range of m is -1 to 2. That means m is greater than -1, less than 2. And you remember, we do not consider the case m less than equal to 2 and greater than equal to -1, because if we take equal to, then this becomes 0, but it is not considerable. Here we have taken the less than 0. Okay.